Okay, this is lecture 15, and this is more on experimental designs and particularly what happens when there are null effects, which means that there's no differences between experimental conditions. This lecture follows the second part of chapter 11 from the Moorlang textbook. So what we want to ask is what happens when a study finds a null effect or a null result. In other words, the independent variable doesn't affect the dependent variable, so there's no significant relationship between the IV or the DV. And in experiments, that just means that there's no difference between experimental conditions, like no difference between a treatment condition and a control condition. Or there's in experiments with multiple conditions, you wouldn't see any differences across those multiple conditions. So typically null effects aren't discussed much in the popular media, and you don't even really see them that much in the published scientific research because published research and therefore media are much more focused on situations in which there is an effect between the IV and the DV. Why would we be interested generally if there isn't an effect of something that we're looking for? Over the next 3 slides, I'm going to talk about some examples from hypothetical studies that were found in the Moorlang chapter that found null effects. And then I'll use these 3 examples to review really 3 major possibilities, which is that the first possibility is that there could be an effect there, but there's not enough difference between your groups, between your experimental conditions to detect that difference. The second thing could also be that there is an effect, but there's within group variability that obscures the group differences between your experimental conditions and obscures the effect. The third possibility is that there's just no difference to be found. So if we think of a study or research as reflecting some kind of true state of affairs in the world, it could be the case that there really is no effect of like a drug or an intervention. It doesn't work. There's no effect. And the results of the study merely confirm that. So a null result can really just mean a null result. It is the case that null effects can actually be hard to find. So oftentimes we get a null effect because we don't have a big enough sample size. We don't have enough statistical power to detect an effect when there really is one. But to be able to conclusively show, hey, no, there's really truly no difference between these groups or between these treatments, you need a very, very, very large sample size in order to confidently conclude that there's no effect. So that's why null effects, they're both easy to find and hard to find. They're easy to find for the wrong reasons. We don't have a properly designed study, or there's not enough participants. But when there is a true null effect in the world in the population, they're hard to find because we very often don't have a large enough sample size to conclusively show that, no, really, it's a null effect. Anyway, let's talk about these 3 examples from the textbook, and I'll come back to them in the lecture. So in this first hypothetical study, you could think about researchers giving participants some amount of money and looking to see whether there's an effect on their happiness one day later. And so you could think about the 3 experimental conditions as either receiving no cash, some cash, or a lot of cash. And even though there's very small differences between these bars, which would indicate that on average there's some difference, what we see here is that there's not a large enough difference between these 3 groups to be statistically significant. That is, we can't rule out that these aren't just merely random influences. Okay, so there's not enough statistical evidence to conclude that there would be a difference at a population level of the effect of this independent variable. So in other words, a null effect, a non-statistically significant difference between these 3 conditions in the study. Okay, so why might that happen? Second example. In this study, researchers had some participants take a GRE prep course, which involved online reading games, and compared this group's score on the GRE reading section to, I think it was a GRE anyway, hopefully I'm not messing it up, but let's just say it was. They compared the online, the group that did a prep class in which they did online reading games to a control group. And again, no difference. Why might that be? And then third example, we've got researchers that are interested in whether creating a state of either low, medium, or high anxiety in participants would affect their logical reasoning ability. And again, very small differences between those the bars in the graph. So we would say that that's not a statistically significant finding, and so there's no difference at a population level. We don't have enough. We have insufficient evidence in our study to conclude that different levels of anxiety are associated with logical reasoning. Okay, in other words, there's a null effect. So in all three examples, these results didn't necessarily come out as expected. The researchers that were doing the study expected to find some difference between their experimental conditions. So what happened? Well, one possibility is when a study has a null effect, it might really be that there's no relationship between the independent variable and the dependent variable. So in this case, maybe the researchers had theoretical and conceptual and even previous research as a justification for why anxiety should be related to logical reasoning, but maybe it's the case that no, it's just there's no relationship there. So a null effect, one possibility is that a null effect is a true effect. There is no relationship between an IV and a DV. Other times, and I would say it would be more common when conducting research to find null results for two other reasons. Okay, it could be because the study wasn't designed well or properly conducted. So there is actually a relationship between the independent variable and the dependent variable. There is truly some causal relationship with the IV causing the DV, but some obscuring factor or factors got in the way of the researchers being able to detect a true difference that exists in the world. So, we'll say that there's two possibilities for null effects due to obscuring factors. Okay. I'll just say that like one possibility that we're going to just kind of put on the side is that null effects are real. Like that's one possibility. But the other two possibility is that there really is a relationship between the IV and the DV, but we didn't find it. And that true relationship could have been obscured for two reasons. One is that there might not have been enough difference between groups, or there might have been too much variability within groups. And so let's look at each of these types in detail. Oh, sorry, a little sloppy there at the number 2. That's fine. All right. So this first reason is that we have a null result because there's not enough difference between our groups, our experimental conditions. And this might occur for a couple different reasons. It can occur because of weak manipulations, because of insensitive measures, particularly an insensitive dependent variable. It can be due to ceiling or floor effects. And so I'm going to review these as well as review how a manipulation check can help detect whether you have a weak manipulation or a ceiling or floor effect. All right, so let's talk about a first possibility of having a weak manipulation. So let's go to the study in which researchers are trying to see if giving people money affects their happiness one day later. Well, one reason why there's no differences between the treatment conditions or between the groups could be because they have a weak manipulation. So for example, if in the no cash condition they got $0, in the some cash condition participants got $1, and in the researcher's operationalization of a lot of cash, let's say was $10. Okay, and then they give people that amount of money, and then they measure their happiness 1 day later. Well, maybe there's no differences between these treatment conditions simply because the manipulation of money is weak. It's not very strong. By today's standards, $10 isn't a ton of money. I guess it depends on who you're giving it to, but that's not life-changing money by any stretch of the imagination, especially when we're interested to see whether there's a lasting effect 1 day later. So one reason that there's no difference between the experimental conditions here is it's just a weak manipulation. The differences between the conditions and the amount of money is just not strong enough to produce a sufficient change in happiness, especially not 1 day later. Okay, so that's the first possibility. The second possibility would be that the dependent variable is insensitive. So this was the study in which researchers had participants take a GRE prep course involving online reading or a control group. And let's just say the conclusion is that taking the GRE prep course didn't have a significant effect on GRE scores. This null result could be because the researchers didn't operationalize their dependent measure, their dependent variable, with enough sensitivity. So let's just say, for example, that the GRE prep course actually does improve the participant scores by 10 points. But if what the researchers did was just take a less sensitive measure and instead just took a look at what percent of participants get a passing score versus a non-passing score, that's a much less sensitive way of operationalizing the dependent variable. Okay, so these numbers are arbitrary. This is making me doubt whether it's the GRE or the SAT or whatever it is, because these numbers don't really correspond to either one of those things. But let's just say we have a standardized test. How about that? And let's just say on the standardized test, a passing score that, let's just say, a college or university would look at in terms of acceptance into like a school program or something like that would be 1,000. So if what the researchers did was operationalize doing better on this standardized test as the pass rate, we would see that operationalizing it kind of at that level doesn't produce a very big effect, that there's not much of a difference, a non-significant difference between the pass rate for online reading games versus the control group. But operationalizing it in a different, more sensitive way, we could see a difference between an improvement of 10 points. So that would be one thing. So it's better to have a very detailed or quantitative dependent variable that you can see kind of would be sensitive to small changes. All right. Here's another way that a dependent variable can be not operationalized very well. And this has to do with a phenomenon called ceiling and floor effects. So a ceiling effect occurs when participants' scores on a dependent variable are clustered at the very high end of the range of possible values. So you could think about in this example, if the standardized test, or if testing whether the taking the standardized test and having people do reading games versus control games resulted in a performance difference, if the researchers gave participants very easy questions, they might see that most participants answered these very easy questions correctly. And so that because scores are clustering on the high end, okay, with people getting close to 100%, we're not able to detect a difference between the two experimental conditions. Just the opposite could happen in the case in which the questions that were designed to measure performance are just too hard. and everyone, or let's just say a majority of participants gets them wrong. Here we're not able to see much of a difference between the two different experimental conditions because everybody is at the floor of performance. So before we were at the ceiling of performance, now we're at the floor of performance. Okay. So you could have both a ceiling and a floor effect, and this can be a function of a poorly operationalized dependent measure asking performance questions that are either way too easy or way too hard. And this happens in educational settings all the time, is that a goal of a instructor is to differentiate between students who study a lot versus study a little. So giving a very easy examination would result in a ceiling effect where almost everybody would get a good grade. That wouldn't differentiate at all between who studied a lot versus who studied a little. Alternatively, if you had an exam that was just so difficult, it was so impossible that even students that studied a ton weren't doing much better than students that didn't study at all. In other words, it was so hard, studying didn't even help. It's like basically random guessing on a multiple choice test or something like that. Okay, so you'd get a floor effect. So what you want to do with your dependent variable is have your questions be kind of, if you're assessing performance, whether that's learning or retention or understanding or skill mastery or something like that, you want to have your assessment kind of be at a moderate amount so that if you've got some intervention that should result in an improvement in performance, you've got room, like you don't hit a ceiling right away. Those folks that would be in an intervention would have the ability to have their performance go up. Alternatively, if you're interested in other types of factors that might like worsen or depress performance, like distractions or stress or something like that, being at a moderate level of difficulty allows that condition room to go down. You're not already at a floor. Okay, so being thoughtful about the operationalization of the dependent variable. It can be the case, however, that both ceilings and floors aren't just a function of a bad operationalization of a dependent variable, but they can be the result of a problematic operationalization of the independent variable. Okay, so let's think about. It's not pictured here, but let's just go back and think about the money and the mood study. It would be possible to get a floor effect by having a not very good manipulation of the money independent variable. So previously we had dollar amounts of 0, 1, and 10. What if the researcher wanted to look at happiness, not one day later, but immediate happiness? Okay, and they decided to give people $0, 25 cents, or $1. And then they asked immediately, how happy does this money make you? And what they might see is a floor effect such that across the board, people might say, doesn't make me very happy at all. $1.25. I mean, it's really nothing by today's standards. So the differences between the groups there, you might have a floor effect with everybody kind of at the bottom of their mood scale or happiness scale because the manipulation, again, wasn't very strong across the board. So you could get a floor effect that way. What about a ceiling effect due to the way that a researcher manipulated the independent variable? Well, here's an example here. So, and we can check these with a manipulation check, but let me just go over how you might get a ceiling effect in this example. So, in the graph on the left, it looks like the different anxiety groups are reporting fairly high levels of anxiety, and there appears to kind of be a ceiling effect where every group is reporting high levels of anxiety. And that could be the case because, let's just say the researcher told the participants in each of the groups that they're going to receive an electric shock. and that was the manipulation of anxiety. And so the low anxiety group was told to expect 10-volt shock, medium anxiety, 50-volt shock, and high anxiety, 100-volt shock. And that's how they operationalize low, medium, and high. But you get a ceiling effect because expecting any amount of shock is enough to produce a high amount of anxiety regardless of the shock's intensity. So as a result, these low, medium, and high levels of voltage wouldn't make any difference. Okay. Now that could be detected. Recall in the example, this particular study wanted to look at the effect of anxiety on reasoning, on logical reasoning. So what you'd want to do is a pilot study where you'd have some sort of a manipulation check. Recall that a manipulation check is a measure that is put in place to evaluate the effectiveness of the manipulation, to see whether the manipulation had its intended effect. A manipulation check can be done in the kind of main study itself, or to really make sure that your manipulation works. A researcher will often do a pilot study, which is a very short and simple study involving different participants ahead of time, just to make sure that the manipulation works. Okay, so an example of a manipulation check could be that the researcher just asks, how anxious are you? Scale of 0 to 10. 0 is not at all and 10 is extremely. How anxious are you right now about this electrical shock? Okay, and so this would be a way, prior to doing the main study, prior to having them do the test of logical reasoning, they would at least want to figure out, does the manipulation of anxiety, does that operate in the intended way? And in the graph on the left, no, it doesn't, because you've got high levels of anxiety across the board. And here, this is what a researcher would be looking for with a manipulation check, is whatever the operationalization of anxiety is, it has its intended effect so that you get significant differences in reported anxiety between your 3 experimental groups. So that way you know that the manipulation works, and then you can go on and test your main dependent variable, okay, your dependent variable of interest, which would be like logical reasoning. We've demonstrated that, if it was the case that those varying voltages of electrical shock produce this result, it's like, hey, that works. The low anxiety group is less anxious. The high anxiety group is more anxious. Now, that's established in a pilot study, and then you see how those different groups do on a test of logical reasoning ability. All right, so that is a review of kind of this first category where you can have null effects because there's not large enough differences between your groups or your experimental conditions. Another cause of null effects might be that there's too much within group variability, okay? And within group variability is otherwise known as error variance or sometimes unsystematic variance. Sometimes people just call it noise. So there's too much noise within condition that is obscuring a treatment effect or an intervention effect or the manipulation of the independent variable. So having too much noise gets in the way of detecting these between group differences. And so we'll review a couple different causes, measurement error, individual differences, and then situation noise. So measurement error just refers to any factor that can inflate or deflate a person's true score on the dependent variable. Okay, so make it higher or lower than it truly is. Very simple example. You could think about a person who's 5'7". They could be measured at 5'7.5" because of the angle or vision of a person using the measuring stick, or that their height might be recorded as 5'6.5" because the person slouched a little bit. Okay, so that's just a measurement error. In psychology, measurement errors happen for a variety of reasons. So, for example, on self-report instruments, when people are being asked about their attitudes or their values or their behaviors, there could be factors like the person's mood when they're taking the survey or the questionnaire, whether or not they got a good night's sleep the night before, which could affect their concentration. Okay, so different kind of not stable but kind of random or haphazard influences might cause people to mark an answer that is artificially high or low, or report behaviors that are artificially more or less. So things like that. Those would be measurement errors. Um, in previous lectures, we've also discussed the use of rating forms by judges or raters to make behavioral observations of people. Rating forms can also be used by raters and judges to code different verbal responses or the response to interviews. So, for instance, some psychological tests that are projective tests, like the Rorschach, the ink blot test, people's responses to what do you see in this image needs to be coded. And so, if you've got different raters that are using criteria differently, they're not quite using definitions properly, they're not scoring things the way that they should be scored, those are measurement errors. So of course the goal is to keep measurement error as small as possible, and so a couple solutions for reducing measurement error. The first would be to use reliable, precise measurements. Research measurement errors are going to be reduced when a researcher uses a measurement tool that is reliable. Okay, so we've talked about reliability as referring to having good inter-rater agreement, for example. Okay, so you got two different raters, and there's somebody's response to the Rorschach, the ink blot. They're scoring it the same way because they're using the same definitions, they're using the same categories, the same criteria, and you know that because you have 2 or 3 people whose scores converge. So that would you've got a precise instrument, and there's a reduction of measurement error that way. You also know that you have a good tool when there's test-retest reliability. Okay, so there's bound to be some amount of measurement error when people take some sort of an inventory or a psychological test one time versus another. Okay, and there's certain psychological variables that we wouldn't expect for there to be much consistency or stability, like mood. But there's other things like personality, values, intelligence, where scores really ought to be the same on different measurement occasions. Okay, so having a precise, reliable, and consistent measure of, say, one's personality or one's intelligence, you're going to see a strong test-retest correlation. Okay, and then just having a valid instrument. Okay, so having good construct validity. Whatever the items or the questions that are part of the inventory, it truly reflects or represents what that psychological construct is. Okay. The other thing to do would be to measure more instances, we'll say. So if it's hard to find a measure that is reliable and valid, one just doesn't exist. Whatever you're measuring, there isn't a good survey or questionnaire inventory for it. By measuring more instances, we could be talking about a couple things. You could measure the same person multiple times, and those multiple measurements could be summed or averaged to get a more stable and accurate measure of that person's, whatever that attribute is. The other thing is just measure more people. So within like 2 different experimental conditions, if all of these kind of like random errors that you could get because of people's mood or whether they're tired or not or things like that, those should balance out. Okay, the more people you get, those random errors should balance out, and that's more likely to be the case when you've got more versus less research participants. Okay, another factor that can create within group variability are individual differences. So the idea with individual differences are that people are just different. Some people are faster runner than others. Some people are smarter than others. Some people are funnier. They have a better personality. Some people are more anxious. Some people are more depressed. People are just different. That's what we mean when we refer to individual differences. And those individual differences can often obscure the effect of an independent variable. So in the graph, you can see how participants who received money were just ever so slightly happier than those that did not receive money, okay? Just barely. But there's a lot of overlap between the two conditions, okay? So what we can say is that there's probably individual differences within each group, right? If you look at this person, Michael, versus the blue dot at the bottom, or if you look at this orange dot, Candace, versus this orange dot, there's a lot of, it's called within group variability, within group differences. And that within group variability is obscuring the fact that money makes people ever so slightly happy. So what was likely going on here is that there could be several important individual differences that are not taken into consideration. We could maybe brainstorm a couple, but let's just say that one variable like age wasn't taken into account. Receiving $1 might make a young person very happy, like who doesn't work and doesn't really have their own money. I know if, I gave my son $1, he'd be very happy about that. But a working adult is probably not going to think too much of it. So age is potentially an individual difference that was not taken into consideration. Another thing could be socioeconomic status. Okay, some people are rich, some people are poor, and that receiving the money is going to influence people that are in that are poor much more than it would influence somebody that is well-to-do. Okay, so it could be the case that we've just got individual differences here. It could be the case that we just also have individual differences in people's kind of baseline level of positive affect. Okay, Michael here could be a naturally happy person, and doesn't really matter. The money doesn't really matter quite so much. He's just always kind of happy. Versus the people kind of at the bottom of each group, they're the grumpies. So there's many different ways in which there can be individual differences in these groups, and that just obscures the small difference. I should comment that unlike measurement errors, which are a feature of the measuring instrument itself, individual differences are stable attributes of people. Okay, so when we're talking about individual differences, we're talking about personality, we're talking about kind of like core affect, okay, like a stable disposition to either be in a happy or grumpy mood. We could also be talking about things like socioeconomic status. So we're talking about stable differences. We're not talking about momentary influences on, say, mood or like lack of sleep or something like that. We're talking about stable differences that you would find across situations and time. So one solution to account for individual differences is something that I've lectured on in the past, which is to use a within groups design. So where you would give the manipulation, you would give both levels of the independent variable to each person. Okay, so here we had Michael, who's the happy person, right? There's this individual difference, these individual differences in people's mood, that Michael just tends to be a happier person than most. If we use a within groups design, Michael, we'll ask Michael's mood when he has no money versus $1. Okay. Same thing with Candace. Candace just happens to be a little bit less happy of a person than Michael, a little bit more grumpy. That's Candace's disposition. But what we can do using this within group design or within subject design is measure Candace's mood in the no money and money condition. So the big advantage here is that because each person receives both levels of the independent variable, the individual differences are controlled for. It's much easier to see the effect when the individual differences aren't kind of obscuring the between group differences. And And so you can also do that with a match group design. So in your sample, you'd have some measure of people's kind of core affect or dispositional tendency to feel happy or sad. And for each person in your no money group, you would match them with somebody in your money group. Okay, so that Michael, here we've got the within subjects design, but Michael would be paired in the match groups design with whoever the dispositionally most happy person is in this condition. Okay, so that's one thing that you can do to control for individual differences. And then the other thing to do, if it's not feasible to use a design that would be a within groups or a match group design, you can just add more participants. And that'll lessen the effect that any one person will have on the group average. So that's the other solution. All right. What else can cause within group variability? Situation noise would be another thing. So these would be external distractions of any kind that obscure the between group differences and cause variability within groups. So this could be anything that would be a distraction. It could be sights or smells or sounds, and it distracts participants from performing or completing whatever the dependent measure is. It ends up adding unsystematic variability to each group. Okay, so that can be minimized by controlling the surroundings of an experiment. So if you're doing some measure of cognitive ability in your testing, you have a quiet room that is free from distractions, okay, and so on. Or if it requires something that where people need to have some sort of vigilance or attention, where the DV is the amount of errors that are made. Again, you have whatever the stimuli is, whatever they're looking at. It's bright enough, it's clear enough. All these things are controlled for by the experiment. So that's very difficult when you administer experiments online or over the web, which is done quite a bit now. It's also an issue, of course, in education when there's online testing, is that as instructors, we can't really control the settings and the environments that you're taking quizzes or examinations in. So that creates all that situation noise. So how do we reduce within group variability? Really, it's about statistical power. So we can think of studies with a higher number of participants, studies that have a strong manipulation, studies that control for individual differences. These are all things that produce statistical power. By power, we're just talking about the likelihood that a study will yield a statistically significant result when the independent variable really has an effect. So the metaphor here is being able to find something by candlelight in this image versus being able to find something when we've got a strong flashlight. So statistical power is enhanced by having that strong light, that flashlight. And again, we do that by increasing sample size, having a strong manipulation, reducing individual differences, for example, by using a within groups or within subjects design. Using different statistical tests. So I won't get into that or elaborate, but different statistical tests, some are more powerful than others. Using a sensitive dependent variable. So all of the solutions that I've talked about are really refer to the idea of statistical power. All right, and this is just a summary chart. This is found in the chapter, but I think that it's useful. So this chart just reviews the reasons or the factors why there might not be enough variability between your levels of the IV. Okay, and then this chart is reasons or factors why there might be too much variability within groups or within levels. And then again, just to remind us that it's also possible that the independent variable in truth has no effect on the dependent variable. Okay? So it's those three reasons. It's that the IV really has no effect, or too much within group variability, or not enough between group variability. And just to finish up, again, kind of where I started, which is just to say null effects may be published less often. They can be just as interesting as experiments that show group differences, I think. And particularly having studies that show null results when people previously thought that there were differences. So gender differences is one domain in particular where null effects are really quite interesting. So over several decades, research on different cognitive abilities, social and emotional abilities, behaviors like leadership. There's been quite a few studies that have found null effects or close to null effects, very small effects between men and women. And I think that those are very interesting examples of when null effects can be just as interesting. But most often they're not. Most often what is interesting is that there is some result or there is some difference. And that's the reason why the research was done in the first place, is that there's some theoretical or conceptual reason to believe that an independent variable will affect a dependent variable in some way. You design the study, you conduct the study. The goal is to try to find an effect. Okay, it's very, very rare that studies are designed for with the intention of finding a null result. More often than not, it's the opposite. So we very rarely see null effects reported in the popular media because they're not published in academic papers or academic journals to begin with. Unfortunately, what this creates is something known as a file drawer problem. Is that you can have studies that were well designed and well executed and had statistical power, but they just didn't find the result. And those null effects aren't published and they aren't reported. They get locked away in a file drawer or whatever the equivalent is now that we have computers and computer files. So anyway, file drawers effect, but that'll be something that'll be a point that I'll come back to and lecture on in subsequent lectures. But for now, I hope that you enjoyed the lecture and now know a little bit more about why we can get null effects in experiments, some of the reasons for them, and how to address null effects or how to resolve null effects by increasing statistical power, increasing sample size, having strong manipulations, using within group design to minimize individual differences, and having a sensitive dependent variable.